Hello again, Math 2. We're on to week 12, MyMathLab examples. Starting off with, I chose number 4. So find the indefinite integral and then check by differentiating. So basically, determine the appropriate substitution. So I would let the u equal the inside. So u equals x squared minus 12. And that's just the first step. So it turns out that A is the correct answer. So you let the u equal the inside part. And then take the derivative of that. And the derivative of x squared is 2x. Now, if you watched the lecture that I did for week 12, which hopefully you watched more than once, I always did du dx, and then I would get my red pen and multiply both sides by dx. But you can do that, since that step is the same every time, you could actually do that as one step right here. So find du dx, the dx would be on the bottom, and then you multiply it over here. And this turns out to have exactly what we need, the 2x dx. So I don't even have to mess with it at all because it matches perfectly. So that means this is going to be the integral of, this becomes u to the third, and then all of this 2x dx gets replaced with just du. All right, now it's time for the red pen. Add 1 to the exponent. That's a 4, so divide by 4. So it's going to become u to the fourth over 4 plus a c. And then don't forget to replace the u with the x squared minus 12. So it's going to be x squared minus 12 to the fourth over 4 plus c. And that would be my answer. And then they say to check your answer. So if you check it, you take the derivative of this. And then that means that the 4 goes in front. And then subtract 1 from the exponent, so that's going to be a 3. And they do have I do have a 4 on the bottom, so that stays a 4 on the bottom. And next I would need to do the chain rule, so the derivative of the inside is 2x. And the derivative of c is 0. So that's why there's nothing right there, because derivative of c is 0. And then when you cancel these 4's, this is exactly the same as the original problem. So that means that my check worked. I did the problem right. After 35 years of practicing calculus, I would hope that I get it right. So this is basically the same, so I don't think I'm going to go through the whole thing, but basically you determine the appropriate substitution. So they're just saying, what should u equal? So the u should equal the t to the sixth plus 8, because that's what's inside the parentheses. And then when you take the derivative of that, that would be 6t to the fifth. And then, like I said, you can save one step. If you just go ahead and multiply, instead of saying du dt, and then the next step moving the dt over, just do that automatically. And then this one, it has t to the fifth dt, but it doesn't have a 6. So I would need to multiply both sides by 1/6. And now this matches this perfectly. And when you do the integral, this 1/6, you could factor it out. And then this would be u raised to the second power, so u squared. And then all of this stuff, the t to the fifth dt, gets replaced with the 1/6, which I already have, and the du. And then the antiderivative for this would be add 1, so that's a 3, and divide by a 3, and then plus c. And then to finish this one off, you could just say this is 1/18, and then replace the u with the t to the 6 plus 8, and that one's done. The next example that I chose is number 12. Find the indefinite integral. And I did do one like this in the lecture, but basically when it's a fraction, you let the u equal the bottom part, and then find the derivative. The derivative of 5x is just going to be a 5, and then you can multiply both sides by dx. And this one has a 1 times dx, it doesn't have a 5 times dx. So like with the last one, I would need to get rid of that 5 by multiplying both sides by 1/5. And then the 1/5 could be factored out on the outside. This fraction would just become 1 over u. And basically the dx that's right here is getting replaced with a 1/5, which I have right there, and a du, which I can just put right there. And this comes from natural log. So the 1/5 could sit there and wait. The antiderivative of 1 over u will be natural log of u. And then put a plus c. The last step, as you may have guessed, is replace the u with the 5x plus 3 from up here. And then just circle it and make a little happy face because we got it right. So the e function. I don't think I did an e function just by itself. So good thing I'm doing it right here. So when you have the e function, then you let the u be whatever the exponent is. 4 minus 5t. And then take the derivative. The derivative of negative 5t will just be negative 5. And then you can multiply both sides by dt. So this one has dt, but it doesn't have a negative 5 multiplying with it. Keep in mind that all of this is in the exponent of the e. So it's really the e is raised to 4 minus 5t, and then the dt is way down here by itself. So the dt does not have anything multiplying with it. So I need to either divide by negative 5 or multiply both sides by negative 1/5. And then that is what the dt equals. So this one is going to become integral. There's the e function, and then we're replacing this with the letter u. And then to replace the dt, we have to have a du, which goes behind the u function, the e to the u function. And this number, you could just factor it out. And then if you remember when we did derivatives, the derivative of e to the something is the exact same thing. Well, for integrals, it's the exact same thing. It's the only function that does that. And of course, I was talking instead of concentrating on my writing. Let me erase this real quick. So the antiderivative of the e function is just the e function. And then put a plus c. And like always, the last step is replace the u with 4 minus 5t. And then there's the plus c, and it's done. So this one was just the first step. So what's the appropriate substitution? This is what the u should equal. So that's a. And I did one similar to this on the lecture, but let's just do this again. So this is the kind where there's an extra x. So since there's a square root, you let u equal what's inside of the square root. Not the whole square root, but just what's inside the square root. And then you take the derivative of that, and the derivative of x is just a 1. Multiply by dx on both sides. And this says you're supposed to have an x times dx. Excuse me. This one says you're supposed to have a 1 times dx. This one says you're supposed to have an x times dx. Well, whenever you're adjusting this, you can only multiply or divide by a number, not by a letter. So that's where I have to use this and find out what x equals. All I need to do is add 10 to both sides. So the left side will become u plus 10. The right side is now just x. And now we're ready for the u substitution. So it's going to be a fraction. On the top is x, so replace x with u plus 10. On the bottom is the square root, and replace what's inside the square root with u. And then dx and du are exactly the same, so this becomes du. And then it's time to do algebra. So when you have two things divided by one thing, you can break that up and say the first one gets divided by the square root of u, plus the second one gets divided by the square root of u. And then I can even do more algebra. This one is u to the 1, and this is u to the half. So when you're dividing, that means subtract the exponents. And 1 minus a half is a half. And for this one, I could, first of all, have the 10 just stay there, and then I could move this to the top, so this is also u to the half, but when you move it to the top, it becomes u to the negative 1/2. And then it's time to add 1 to the exponent. This is 1/2 or 3/2, so divide by 3/2. Add 1 to this, 1 minus a half is a half, so divide by a half. And then we're almost done. So this needs to be inverted. It's going to become a 2/3. And then this becomes u to the 3/2. And because I know I'm going to have to replace the u, sometimes I don't even write the u, I just write parentheses to save a little bit of time. It saves me one step at the end. Then move on to the next one. If you invert this, it becomes a 2, and 2 times 10 is 20. And then the u is raised to the 1/2, and now I put the plus c. And I always have to replace the u with what it equals at the end, so that's why I left these blank. So now I can replace the u with x minus 10 and x minus 10. And then it's done. So this one is a very easy problem, but I just wanted to show you what they're talking about. They're saying first, use substitution method. So what's inside the parentheses? You go u equals the 5x plus 9. And then take the derivative of that. Well, the derivative of 5x is just 5. And originally this would say du dx, and then multiply both sides. So this is saying you're supposed to have a 5 times dx, and it has a 5 times dx. So that means it's set up perfectly. I don't even have to multiply or divide anything. So this is going to become, in the parentheses, replace that with u, and then the 5 times dx gets replaced with just a du. So this is basically a u to the 1. So if you add 1, that will become a 2, and then divide by 2. So it's u to the 2 over 2, and then put a plus c. And you guessed it, replace the u with the 5x plus 9. And then that one's done. So they said to use the u substitution, and then also do it without u substitution. So this does not work very often, but they are just trying to make the point that sometimes you can use u substitution, but sometimes there's an easier way. Like you could just do algebra first, and it's only because this is not squared or cubed. If it was, I can't distribute, but because it's just a 5x plus 9 in parentheses, then I could distribute. So that would be 5 times 5, that's 25x, plus 5 times 9 is 45. And then this one has an exponent of 1, so the antiderivative will be x squared over 2, and the 25 will just sit there. And the antiderivative of the number 45 is 45x. And then plus c. So these are both correct answers. And if you multiplied this one out and simplified it, then you would get, and you would show that they're the same thing. Okay, just one more. Because what are they talking about here? So they're getting you to describe a differential equation, but really you just have to find the derivative, okay? So the derivative of the e function is the e function. And then because of the chain rule, I need to take the derivative of this, which is -1, and multiply by that -1. And then they're saying, explain the relationship between the two. So in other words, when you compare this to this, what's the relationship? Well, that's the same as that, except this one is multiplied by a -1. So let's see, which one is it? Well, this says it's -14 times. No, it's not -14 times, it's -1 times. This says they're exactly the same. No, they're not exactly the same because this one has an extra -1. The derivative is -1 times e raised to the, okay, right here, they're thinking that when you took the derivative, you made the mistake of saying the derivative of this is, somehow they're saying you then subtracted 1 from the exponent. But with the e function, that's not how you do it at all. So this one is out. The derivative of f of x is -1 times the original problem. And that is it, because there's the original problem. Yes, -1 times it. That is A. Oh, look, I got an A on this one.